Have you ever gazed up at the night sky, mesmerized by the twinkling stars scattered across the vast expanse above? Each tiny point of light represents a distant sun, perhaps orbited by planets of its own. The sheer scale of the universe is difficult to comprehend, stretching out in all directions for unimaginable distances. We find ourselves on a tiny planet, orbiting an average star in a galaxy amongst billions. Yet, despite our seemingly insignificant place in the grand scheme of things, the story of the universe is intimately connected to our own. The early universe was a turbulent and unforgiving place. Temperatures were incredibly high, and radiation flooded the cosmos. Over time, however, the universe continued to expand and cool, allowing for the formation of more complex structures. Quarks combined to form protons and neutrons, which in turn came together to create the first atoms, primarily hydrogen and helium. These primordial elements, forged in the crucible of the Big Bang, became the raw materials from which stars and galaxies would eventually form. Gravity, the architect of the cosmos, began to exert its influence, pulling together vast clouds of hydrogen and helium gas. As these clouds collapsed under their own weight, they began to heat up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. With the birth of the first stars, the universe emerged from its cosmic dark ages, bathed in the light of these newly formed celestial furnaces. These first stars were massive and short-lived, but their deaths would pave the way for the formation of heavier elements and the complex structures we see in the universe today. The stage was set for the next chapter in the cosmic story, a chapter filled with the birth and death of stars, the formation of galaxies, and ultimately, the emergence of life itself. The universe, moments after its explosive birth, was a chaotic sea of energy. As it expanded and cooled, raw energy condensed into matter, forming the first elementary particles. Quarks combined to form protons and neutrons, the building blocks of atoms. Initially, these particles were too energetic to stick together. The universe was a hot, raging inferno. As it expanded, it cooled, like a simmering primordial soup. This cooling allowed the universe to reach a critical temperature. Protons and neutrons began to clump together, forming atomic nuclei. Drawn by the strong nuclear force, they marked the birth of the first atomic nuclei. These nuclei were the seeds of elements, the ingredients for stars, planets, and life. Out of the primordial soup crafting the cosmic cookbook. The early universe, teeming with newly formed atomic nuclei, was still a far cry from the universe we observe today. The cosmos, at this point, was essentially a giant fusion reactor, a place where the simplest and lightest elements, hydrogen and helium, were forged in tremendous quantities. This process, known as Big Bang nucleosynthesis, was like a cosmic cookbook with the universe as its kitchen. Imagine a recipe with only two main ingredients, protons and neutrons. In the intense heat and pressure of the early universe, these ingredients collided and fused together, creating new elements. Single protons, the nuclei of hydrogen atoms, combined to form helium nuclei, consisting of two protons and two neutrons. This process of nuclear fusion released tremendous amounts of energy, bathing the universe in a brilliant light. It's this light, stretched and redshifted over billions of years, that we still detect today as the cosmic microwave background radiation, a faint echo of the Big Bang itself. But the cosmic cookbook at this stage was limited. The intense conditions of the early universe only allowed for the creation of the lightest elements, primarily hydrogen and helium, with trace amounts of lithium and beryllium. The heavier elements, the ones essential for planets and life, would have to wait for a later chapter in the cosmic story, a chapter written in the hearts of stars. The cosmic symphony begins. Gravity orchestrates the universe. As the universe continued to expand and cool, a new force began to exert its influence: gravity. This invisible force, the weakest of the fundamental forces yet the one that acts over the largest distances, began to sculpt the universe, drawing matter together into increasingly complex structures. Imagine the early universe as a vast, diffuse cloud of hydrogen and helium gas. Within this cloud, tiny variations in density, remnants of the quantum fluctuations present at the very beginning, created regions of slightly stronger gravitational pull. These regions acted like seeds, drawing in surrounding gas and dark matter, an invisible form of matter that interacts gravitationally but does not emit light. Over millions of years, these seeds of structure grew, forming a cosmic web of filaments and voids. The filaments, vast rivers of gas and dark matter, became the scaffolding upon which galaxies would eventually form. The voids, regions of relatively empty space, represented the spaces between these cosmic filaments. This process of structure formation, driven by the relentless pull of gravity, marked a turning point in the evolution of the universe. The once smooth and homogeneous cosmos was now becoming clumpy and structured, setting the stage for the birth of stars and galaxies. Let there be light. The dawn of stars ignites the cosmos. Within the cosmic web, a spectacular transformation unfolded. Dense clumps of hydrogen and helium gas contracted, becoming hot and dense. A critical threshold was reached, and the first stars were born. These colossal stars were much larger and hotter than our sun. Nuclear fusion ignited, releasing torrents of energy. Hydrogen atoms fused to form helium, illuminating the darkness. This starlight ended the cosmic dark ages. Ultraviolet radiation ionized the gas, making the universe transparent. The dawn of stars was pivotal in cosmic history. It set in motion the creation of heavier elements, leading to planets and life. The universe, once dark, was now ablaze with billions of stars. The universe, illuminated by the first generation of stars, was far from static. Gravity, the tireless sculptor of the cosmos, continued to shape its destiny. Those early stars, scattered throughout the universe, were not randomly distributed. They clustered together, drawn by the invisible hand of gravity into vast rotating clouds of gas, dust, and stars, the precursors to galaxies. Imagine these proto-galaxies, colossal swirls of cosmic raw material, each a nursery for billions upon billions of stars. Within these swirling clouds, gravity orchestrated a delicate dance. Dense regions of gas collapsed, igniting new stellar nurseries, while vast clouds of dust obscured the light from some stars, creating breathtaking nebulae. As these proto-galaxies matured, they began to take on distinct shapes, influenced by their rotation, the distribution of matter within them, and the occasional gravitational tug from their neighbors. Some, like our own Milky Way, formed majestic spiral galaxies, with graceful arms of stars, gas, and dust, winding outward from a central bulge. Others, through collisions or internal processes, evolved into elliptical galaxies, vast, smooth, and often ancient collections of stars. And still others, perhaps the most chaotic and enigmatic, became irregular galaxies, their shapes defying easy classification, shaped by the turbulent forces at play in the early universe. Galaxies, though vast and seemingly isolated, are not solitary islands in the cosmic sea. They exist within a complex web of gravitational interactions, constantly tugging and pulling on one another, sometimes with dramatic consequences. Galactic collisions, once thought to be rare events, are now understood to be common occurrences throughout the universe's history. Imagine two galaxies, each a swirling disk of stars, gas, and dust on a collision course. As they draw closer, their gravitational fields begin to interact, distorting their shapes and sending ripples of energy through their structures. Stars, flung about like sparks from a cosmic bonfire, are ejected into intergalactic space, while vast streamers of gas and dust are drawn out, creating breathtaking tidal tails. The merging process itself can take hundreds of millions, even billions of years to complete. During this time, the galaxies may pass through each other multiple times, their stars and gas intermingling in a chaotic dance. Eventually, they will coalesce into a single larger galaxy, often with a shape and structure dramatically different from either of its progenitors. These galactic mergers, though seemingly destructive, are actually engines of creation. The compression of gas and dust during a merger can trigger intense bursts of star formation, lighting up the merging galaxies with the brilliance of countless newborn stars. As astronomers delved deeper into the study of galaxies and their movements, they stumbled upon a profound mystery, one that continues to challenge our understanding of the universe. Galaxies, it turned out, were not behaving as they should based on the visible matter they contained. They were rotating faster than expected, and clusters of galaxies were held together by a gravitational force far stronger than their visible mass could account for. This discrepancy led to the astonishing realization that there must be more to the universe than meets the eye. There must be a form of matter, invisible to telescopes, that interacts gravitationally but does not emit light, a mysterious substance known as dark matter. Further observations, particularly of the expansion of the universe, revealed another perplexing phenomenon. The expansion, rather than slowing down as gravity pulled matter together, was accelerating. This unexpected acceleration implied the existence of another mysterious entity, dark energy, a force that permeates all of space, counteracting gravity and driving the accelerated expansion. The nature of dark matter and dark energy remains one of the greatest unsolved mysteries in modern astrophysics. Together, they constitute a staggering 95% of the total mass energy content of the universe, leaving only a meager 5% for the familiar matter that makes up stars, planets, and ourselves. A universe of possibilities, the diversity of galaxies. The universe, as revealed by powerful telescopes, is a tapestry woven with an astonishing diversity of galaxies. From majestic spirals with brilliant star-forming regions, to smooth elliptical giants with older, redder stars, to chaotic, irregular galaxies, each with unique characteristics, the cosmos showcases nature's boundless creativity. Some galaxies harbor supermassive black holes, actively feeding on surrounding gas and dust. These black holes release tremendous energy, often outshining their host galaxy. Dwarf galaxies, smaller and fainter, often orbit larger galaxies like satellites. They may hold clues to the early universe. Studying galaxies reveals the cosmos's vastness and complexity. Each galaxy is shaped by its history and environment. Within these cosmic islands, the universe's story unfolds, from star birth to planet formation and the possibility of life. Stellar nurseries, where stars take their first breath. Across the vast canvas of space, within the swirling arms of galaxies and the depths of interstellar clouds, a celestial drama unfolds, the birth of stars. These stellar nurseries, known as nebulae, are regions of intense activity, where gravity gathers clouds of hydrogen and helium gas, seeding the universe with the raw materials for new generations of stars. Imagine a nebula, a vast cold cloud of gas and dust, perhaps light years across, drifting through the interstellar medium. These cosmic clouds, though seemingly serene, are battlegrounds between gravity and pressure. Gravity, the relentless sculptor, seeks to draw the gas and dust inward, while pressure, generated by the heat within the cloud, pushes back, resisting collapse. Over time, gravity gains the upper hand. Within the densest regions of the nebula, pockets of gas and dust begin to collapse under their own weight, drawing in more and more material from their surroundings. As these pockets contract, they heat up, their internal pressure increasing as they fight against gravity's relentless pull. This delicate dance between gravity and pressure can last for millions of years, a cosmic tug-of-war that determines the fate of these collapsing clouds. If gravity wins decisively and the cloud collapses rapidly, a star is born. If the collapse is more gradual, or if other factors intervene, a different fate may await. A star's life cycle, a cosmic ballet of fusion and gravity. Once a protostar ignites, its life is a balance between gravity and nuclear fusion. As stars age, they transform, ending as white dwarfs or exploding in supernovae. Stellar death and rebirth, supernovae, neutron stars, and the cycle of elements. Massive stars end in supernovae, forging heavy elements. These elements seed new stars and planets. Neutron stars and pulsars are remnants of these explosions. Into the abyss, black holes where gravity reigns supreme. Massive stars can collapse into black holes, regions where gravity is inescapable. Approaching a black hole warps space-time, slowing time near the event horizon. Black holes influence surrounding matter, playing a key role in galaxy evolution. A cosmic dance, the birth of our solar system. A nebula collapsed under gravity, forming a protoplanetary disk. The proto-sun formed at the center, pulling in gas and dust. Planets began to form within this disk. From dust to planet, the formation of Earth. Planetesimals collided and stuck together, forming larger bodies. Inner planets formed from rocky materials, while gas giants formed further out. A spark of life. The genesis of biology on early Earth. Early Earth was volatile, but life emerged from organic molecules. Simple molecules formed complex structures, leading to self-replicating life. These early organisms evolved, diversifying over time. A time of upheaval, shaping Earth's destiny. The late heavy bombardment reshaped Earth, delivering water and organic molecules. Volcanic activity formed a stable atmosphere, setting the stage for life. From single cells to complex creatures, life's grand experiment. Early life evolved through natural selection, leading to photosynthesis. Oxygen transformed the atmosphere, paving the way for multicellular life. The Cambrian explosion, life's Big Bang. The Cambrian explosion saw rapid diversification of life forms. This period established the basic body plans of major animal groups. Triumph and tragedy, mass extinctions and the resilience of life. Mass extinctions, like the one that ended the dinosaurs, reshaped life on Earth. These events allowed surviving species to diversify and evolve. A planet transformed. The rise of humans. Homo sapiens emerged in Africa, developing language and tools. We colonized the planet, impacting Earth's systems. Our future depends on recognizing our interconnectedness and sustainability. Our cosmic legacy. From a spark in the void to the intricate dance of galaxies, from the birth and death of stars to the emergence of life on our pale blue dot, we have journeyed through the universe's epic saga. We've witnessed the awe-inspiring power of gravity, shaping cosmic structures on scales both grand and minute. We've marveled at the intricate processes that forged the elements within the hearts of stars. Those same elements now composing our very bodies. The universe, once a silent expanse of hydrogen and helium, now echoes with the music of creation and destruction, a symphony played out across billions of years and light years. We, the products of this grand cosmic experiment, find ourselves at a pivotal juncture, our actions echoing through the delicate balance of Earth's ecosystems. The future, like the vastness of space itself, stretches before us, filled with both promise and uncertainty. Will we succumb to the challenges we have created, or will we rise to the occasion, drawing upon the same ingenuity and resilience that allowed life to flourish on our planet for billions of years? As we stand at this crossroads, let us remember that we are not just inhabitants of Earth, but citizens of the cosmos. Our story is inextricably linked to the grand narrative of the universe, a story that began billions of years ago and continues to unfold with each passing moment. Let us strive to become worthy inheritors of this cosmic legacy, preserving the delicate balance of life on our planet and shaping a future where humanity and nature thrive in harmony. Our cosmic legacy. From a spark in the void to the intricate dance of galaxies, from the birth and death of stars to the emergence of life on our pale blue dot, we have journeyed through the universe's epic saga. We've witnessed the awe-inspiring power of gravity, shaping cosmic structures on scales both grand and minute. We've marveled at the intricate processes that forged the elements within the hearts of stars. Those same elements now composing our very bodies. The universe, once a silent expanse of hydrogen and helium, now echoes with the music of creation and destruction, a symphony played out across billions of years and light years. We, the products of this grand cosmic experiment, find ourselves at a pivotal juncture, our actions echoing through the delicate balance of Earth's ecosystems. The future, like the vastness of space itself, stretches before us, filled with both promise and uncertainty. Will we succumb to the challenges we have created, or will we rise to the occasion, drawing upon the same ingenuity and resilience that allowed life to flourish on our planet for billions of years? As we stand at this crossroads, let us remember that we are not just inhabitants of Earth, but citizens of the cosmos. Our story is inextricably linked to the grand narrative of the universe, a story that began billions of years ago and continues to unfold with each passing moment. Let us strive to become worthy inheritors of this cosmic legacy, preserving the delicate balance of life on our planet and shaping a future where humanity and nature thrive in harmony. Our cosmic legacy. From a spark in the void to the intricate dance of galaxies, from the birth and death of stars to the emergence of life on our pale blue dot, we have journeyed through the universe's epic saga. We've witnessed the awe-inspiring power of gravity, shaping cosmic structures on scales both grand and minute. We've marveled at the intricate processes that forge the elements within the hearts of stars, those same elements now composing our very bodies. The universe, once a silent expanse of hydrogen and helium, now echoes with the music of creation and destruction, a symphony played out across billions of years and light years. We, the products of this grand cosmic experiment, find ourselves at a pivotal juncture, our actions echoing through the delicate balance of Earth's ecosystems. The future, like the vastness of space itself, stretches before us, filled with both promise and uncertainty. Imagine a really big empty space. It goes on forever in every direction. No light, no warmth, just nothing. All the bright stars we see now? Gone. Just tiny bits of energy left behind. This is how scientists think the universe might end. Everything just stops. A bit scary, no? But why worry about something so far away? We humans are curious. We want to know where we came from and what will happen in the end. By studying space, we learn more about how everything works. We understand how special our time is. And maybe, by looking at the universe's end, we learn about ourselves. This journey isn't easy. It can be a little frightening, but it's a journey worth taking. It will teach us about existence. So get ready. We're going on an adventure to the end of everything. It's going to be mysterious and maybe a little spooky. Before we talk about the universe's end, let's understand our place in it. Think of the universe like a tiny seed, packed with everything. Scientists call this a singularity. About 13.8 billion years ago, boom! The Big Bang happened. Space, time, everything started. The universe grew bigger and cooler. Atoms formed stars and galaxies, creating the universe we see today. But the universe won't last forever. The same forces that make it grow also set the stage for its end. Dark matter and dark energy are mystery ingredients affecting the universe's fate. Will the universe fade away or end with another Big Bang? The answers are out there waiting for us to discover them. So friends, we think of time as a straight line, going from yesterday to today to tomorrow, right? But in the vastness of space, time is different. Stars live and die. Galaxies are born and fade away. And just like everything else, even time itself will one day end. The universe isn't just sitting still. It's always changing, always growing. And like all living things, the universe will also have a lifespan. One day it will reach its end. Join me as we explore how the universe might end. So friends, our journey to the end of everything starts with something simple, something you can almost picture: expansion. Think of a balloon, getting bigger and bigger. That's what our universe is doing ever since the Big Bang. All the galaxies, those big groups of stars, are moving away from each other. Not because they're being pushed, but because the space between them, like the balloon's rubber, is stretching. But here's the thing. This stretching isn't always the same speed. It's getting faster thanks to something mysterious called dark energy. Imagine it like an anti-gravity, pushing everything apart. making the balloon inflate faster and faster. The galaxies painted on it, whoosh, moving away quicker and quicker. Now, this faster and faster stretching has big consequences. As the universe gets bigger, its energy, like the heat inside our balloon, spreads thinner and thinner. Everything cools down slowly, becoming colder and darker. This expansion, my friends, isn't just some interesting fact. It's a big clue to how the universe might end. Will it keep stretching forever, with galaxies becoming lonely islands in a vast empty space? Or will this stretching slow down, maybe even reverse? These are the big questions keeping scientists awake at night, and the answers, as we'll soon see, are very, very mysterious. So, friends, we talked about the universe expanding, right? Everything moving away from everything else. But what about the energy that makes all this happen? The energy that makes stars shine, galaxies swirl, and even makes life possible? Well, even energy isn't free from the rules of the universe. There's this important rule called the second law of thermodynamics. Big word, simple idea. It says that things tend to get messy over time. Scientists call this messiness entropy. Like, imagine you have a nice hot cup of chai. At first, it's all warm and cozy. You can feel the heat. But leave it out for a while and it gets cold, right? The heat spreads out into the room, and you can't use it to warm yourself anymore. That's entropy. The same thing happens to the whole universe. As it gets bigger and colder, the energy spreads out thinner and thinner. Like that chai cooling down, the energy becomes less useful. Scientists call this heat death. In this heat death, energy still exists. It's just everywhere, but it can't do anything useful. Stars will stop shining, even black holes will disappear, and the universe will become a cold, dark, and empty place. So friends, imagine everything in the universe, slowly becoming messy. That's entropy. It's like a naughty little kid who just to mess up a tidy room. The universe, you see, is also slowly getting messier. Think of a beautiful sandcastle on the beach, all fancy towers and arches. That's like the universe at the beginning, nice and organized, low entropy. But then the waves come crashing in. Whoosh, whoosh. The waves, they are like entropy. Slowly they break down the sandcastle, bit by bit, until finally it's just a messy pile of sand. That's what's happening to everything in the universe, even the big shiny stars and the swirling galaxies. Entropy is slowly making them messy too. Stars, they burn bright, then fade away into white dwarfs or black holes. And the galaxies, they drift apart like lost toys in a giant playground. This whole thing, this entropy business, it takes a very long time, longer than you can even imagine. But eventually, everything becomes the same temperature. Nothing exciting happens anymore. It's like a party where everyone is too tired to dance. This is what scientists call the big freeze. A bit sad, no? The universe just frozen. Stars, those shiny bright lights in the sky, aren't forever. They're born, they live, and then they die. Big stars live fast and die young, exploding as supernovas. Smaller stars like our sun fade slowly, becoming white dwarfs. Over trillions of years, they cool into black dwarfs. When stars die, they leave behind elements essential for life. Without new stars, the universe becomes empty, like a garden without seeds. Part 5. Black holes, the kings of the end. Imagine the universe getting very, very old. Stars become dim and galaxies move far, far away from each other. One thing will still be there, stronger than everything else. Black holes. These mysterious things, born from dead giant stars or hiding in the middle of galaxies, are super strong. Their gravity is like a giant magnet, so strong that nothing, not even light, can get away. As the universe gets older and older, black holes become bigger and bigger, slowly eating anything that comes too close. Stars, planets, even whole galaxies will be pulled towards these giant space monsters. Everything they eat makes them even bigger, but even black holes can't live forever. A very smart scientist named Stephen Hawking discovered something called Hawking radiation. It's like a tiny leak. Black holes very, very slowly lose tiny bits of themselves into space. This takes a long, long time, much longer than we can even imagine. But this tiny leak, this Hawking radiation, gives us a little bit of hope. When black holes finally disappear, they give back the energy they ate. Maybe, just maybe, this energy could help make new things in the universe, a very, very long time from now. Part 6. A Glimmer in the Darkness. The big freeze sounds grim, doesn't it? Like the universe just gives up. But there might be a tiny spark of hope, a chance for a new beginning. The quantum vacuum isn't empty. It's like a bubbling pot of virtual particles. Maybe enough to make a new universe. Or a cyclic universe. The big freeze could be a doorway to a new beginning. These ideas give us hope. Maybe the universe can be reborn, like a phoenix. Part 1. A universe falling apart. The big freeze might seem like the most natural end, but what if the end is a loud bang? A huge cosmic explosion. This is the Big Rip, a sudden and violent end. Imagine the universe as a woven cloth of space and time. In the Big Rip, these threads are torn apart, torn by a force that gets stronger over time. This force is called phantom energy. Phantom energy is a mysterious dark energy. It gets denser as the universe expands, different from regular dark energy. Phantom energy makes the universe expand faster. Galaxies feel the pull, stars are pulled apart. Even space and time can't handle the pressure. It starts to unravel like a smooth sheet getting wrinkly. The universe unravels, distorted and torn. So, friends, at the heart of this Big Rip idea is something called phantom energy. It's like a mysterious type of dark energy, but way stranger than anything we've seen before. You see, regular dark energy pushes space apart at a steady pace. But this phantom energy, it's different. As the universe gets bigger, this phantom energy pushes. Imagine a fire, right? But instead of wood, it burns on something that gets hotter and fiercer the more it burns. That's what phantom energy does to the universe. It makes it expand faster and faster like crazy. Now, we haven't actually phantom energy. It's still a what if. But the way the universe is speeding up, well, it could be a clue that this phantom energy is secretly pulling the strings. If this phantom energy real, things get interesting. The universe won't just fade away. It'll be a big, dramatic ending, like a grand finale where everything, even space itself, gets ripped apart. So now imagine these beautiful galaxies, these islands of stars and gas, like, floating in space. They look so peaceful, right? But something terrible is happening. This phantom energy, this mysterious force, it's getting stronger and stronger. It's like a cosmic tug of war. Imagine a rope. On one side, you have gravity holding everything together nice and tight. On the other side, you have this phantom energy pulling everything apart. And guess what? Phantom energy is winning. The universe is expanding, getting bigger and bigger, faster and faster. And this phantom energy is making it happen. So gravity, which holds the galaxies together, it starts to lose. It's like trying to hold sand in your hand. The harder you squeeze, the more it slips away. The stars in the galaxy, they start to feel this, especially the ones at the edge, far away from the center. They are like the loose threads on a sweater. They get pulled away first, flung out into the darkness of space. Whoosh, gone. Then the beautiful spiral arms of the galaxies, they start to stretch and twist, like someone's pulling taffy. They lose their shape. Even the center of the galaxy where everything is packed tight, even that starts to break apart. It's like the universe is being ripped apart, thread by thread. So, the Big Rip, it doesn't just stop at tearing apart galaxies. It goes much, much further. Imagine a piece of cloth, stretched tight, okay? Now, as this phantom energy gets stronger, it's like invisible hands are pulling this cloth, stretching it, stretching it, stretching it, more than it can handle. This cloth, imagine it's like space and time. It starts to tear. Little rips at first. But then, they get bigger and bigger like giant cracks. And then, at the very end of the Big Rip, the universe just breaks apart like a shattered mirror. Part 5. Oblivion, the ultimate fate. So in the last moments of the Big Rip, as the universe keeps stretching out faster and faster, even the smallest bits of stuff wouldn't be safe. Atoms, the tiny things that make up everything we see and touch, they would be ripped apart. Their protons, neutrons, and electrons all scattered everywhere. Imagine something so strong that it can pull apart even the tiny bits inside atoms. As this phantom energy gets super strong, this is exactly what happens. Electrons would be pulled away from their atoms, leaving behind a bunch of, well, let's just say it wouldn't be good. But the breaking doesn't stop there. Protons and neutrons, the things inside the center of atoms, are made of even smaller bits called quarks. They're held together really tightly. But in the Big Rip, even that strong hold would break. Protons and neutrons would dissolve into these tiny quarks, making the universe a big soup of tiny particles. The universe, which used to be full of stars, galaxies, and planets, would just be a mess of tiny particles. Space and time, as we know them, would be gone. What's left would be so strange and different from what we know. It's hard to even imagine. This is what could happen in the Big Rip. Everything gone. Even the smallest bits of everything ripped apart, leaving behind a big, empty nothing. Part 6. A tiny bit of hope. This Big Rip thing sounds super scary, right? Like the scariest ending ever. But guess what? There might be a tiny bit of hope. Maybe the universe can start over even after such a crazy end. Part 16. The universe backwards. Imagine, if you will, a universe not going outwards but inwards. Imagine everything slowing down, stopping, and then going back. Like a movie playing in reverse. This is the Big Crunch idea. It's like the universe going back to how it all started billions of years ago. The big question is, what makes this happen? Gravity. Everything in the universe, all the stars, planets, everything, pulls on each other. In the Big Crunch, this pulling, this gravity, becomes stronger than the pushing that makes the universe bigger. Imagine a game of tug-of-war, okay? Gravity is winning, pulling everything back together. So what happens next? Everything changes. The universe, which is getting bigger now, starts to get smaller. Galaxies, moving away from each other now, start coming closer. It's like a dance, but instead of moving apart, they come together. Closer and closer. This Big Crunch is very different from the Big Freeze or the Big Rip, which we talked about before. Those are about the universe going on forever, getting bigger and colder or ripped apart. But the Big Crunch, it has a beginning, a middle, and an end. It's like a big circle from start to finish, and then back to the beginning again. So, picture this, the Big Crunch. Gravity is the star of the show. It's like this invisible hand, right? Pulling everything closer, rewinding the universe's story. Gravity keeps planets spinning around stars, forming galaxies. And in this story, gravity decides everything. The secret to gravity's power is how packed the universe is. Right now, the universe is getting bigger because of dark energy, which pushes against gravity, and the leftover energy from the Big Bang. But if there's enough stuff, gravity becomes super strong. It's like a tug of war, and gravity wins. The Big Crunch is kind of like that. Gravity pulls everything back together. Galaxies start to get closer and closer. They bump into each other more and more. It would be a huge cosmic light show. with stars flying everywhere and gas clouds crashing, making new stars pop up like firecrackers. So imagine this. Gravity, like a strong, invisible hand, starts to pull everything in the universe closer. It's like rewinding a movie, but this movie is the entire universe. This is the Big Crunch. A beautiful but scary cosmic dance begins. One of the first things we'd notice is the universe getting warmer. You know the Big Bang? It left behind a little bit of heat, like the embers of a fire. We call it the cosmic microwave background. It's very, very cold now, but in the Big Crunch it would start heating up. And the night sky? Imagine it filled with more and more stars, shining brighter and brighter. Galaxies like giant swirling dancers would rush towards each other. Their light would turn bluer, showing how fast they're coming closer. New stars would be born everywhere, like sparks in a giant bonfire. The universe would become a giant, bright oven. But these new stars wouldn't live long. The universe shrinking around them would make them grow old very fast. So friends, this big crunch, this big collapse, it depends on one very important thing: how the universe is. You see, this thickness, we call it density. It tells us how much stuff like stars, planets, and all that is packed into a certain space. This density will decide if gravity is strong enough to stop the universe from growing bigger and pull everything back together. There's a special thickness, a perfect balance. We call it the critical density. If our universe is thicker than this critical density, then gravity is the big boss. It slows down the expansion, and then everything goes back in the Big Crunch. But what if the universe is less thick than this critical density? Then gravity is not so strong. It can't stop the universe from growing. The universe keeps getting bigger and bigger, but slower and slower, until everything becomes very cold and very dark. We call this the Big Freeze. Brrr. Figuring out the thickness of the universe, this density, is very tricky business. Our scientists, these astronomers and cosmologists, they have to count all the stars, galaxies, even invisible things like dark matter and dark energy. And guess what? This dark matter and dark energy, they might be most of the universe. It's like a big mystery puzzle. Part 5. The Echo of the Big Bang. Imagine this. As the Big Crunch gets stronger and stronger, the whole universe becomes super, super hot. Like hotter than anything we can think of. Remember that cosmic microwave background radiation we talked about? Well, now it's like a super-powered heater, blasting everything with incredibly strong energy beams. Galaxies, which are now squished together like sardines in a can, become one giant, hot, heavy lump. Stars can't handle the pressure anymore. They're getting squeezed so hard, some explode like giant firecrackers, supernovae, and others just collapse into black holes. And the black holes? Oh boy, it's their party now. They're like kids in a candy store eating everything they can get their hands on. Bigger and bigger they grow, swallowing stars, planets, anything that comes close. Their event horizons, the point of no return, get wider and wider as they gobble up more and more. In the very last moments, even these giant black holes can't escape. They crash into each other, making huge ripples in space and time, like waves in a pond. The universe, which was once so big and full of amazing things, becomes just one tiny dot. A single point, unbelievably hot and heavy. Part 6. A new beginning or a cosmic echo. The Big Crunch makes us ask a big question. What happens the universe shrinks back? Is it really the end, or could it start another Big Bang? Could a brand new universe be born? Some scientists think the universe might expand and shrink again and again, like a balloon. Others think the singularity, that tiny super hot point, is the real end. They think even the rules of physics, the rules of, don't work there. So what happens after the Big Crunch? It's one of the biggest mysteries about space. Scientists are still trying to figure it out. Part 1. Secrets of the Dark Universe. Imagine a universe hidden in the shadows. A dark universe filled with mysterious things called dark matter and dark energy. We can't see dark matter with our biggest telescopes, but like an unseen hand, it pulls things together with its gravity, shaping the universe. Then there's dark energy. It's like anti-gravity, pushing everything apart and making the universe expand faster and faster. These mysterious forces, dark matter and dark energy, control everything. They decide the future of the universe. It shows us that the universe is much stranger and more mysterious than we ever thought. Part 2. The Mysterious Presence. Discovering Dark Matter. So we start with a puzzle about how galaxies move. The stars inside them, they're zooming around too fast. Faster than they should if we only count what we can see. It's like there's a hidden helper, something invisible giving them an extra gravitational push. We call it dark matter. This unseen like cosmic glue, it's what holds galaxies and groups of galaxies together. But what it? That's one of the biggest head-scratchers in space science today. So, friends, this dark energy, it's like a reverse gravity, pushing everything away from everything else. Faster and faster. Imagine like blowing up a balloon, but the balloon keeps expanding faster and faster. When scientists found this out, they were shocked. It made the universe even more of a puzzle. What this dark energy? We don't really know. Maybe it's something about space itself, or maybe, just maybe, it's a whole new kind of force. Something we haven't even dreamt of yet. Part 4. A cosmic tug-of-war. Like a big game of tug-of-war in space, gravity and this mysterious thing called dark energy are fighting. You see, dark matter, it's like the anchor, pulling everything closer. But dark energy, it's like a powerful spring, pushing everything further and further away. Who wins this fight, this cosmic tug-of-war, will decide how everything ends, the whole universe's fate. Part 5. The Invisible Architects, Shaping the Universe's Destiny. Dark matter and dark energy, even though we can't see them, are like the builders of our universe. They decide its future. Dark matter, think of it like the scaffolding of a building. It holds everything together, giving galaxies their shape. Dark energy, on the other hand, is like a powerful engine, pushing the universe outwards, making it expand. Now these two, dark matter and dark energy, are playing a cosmic tug-of-war, and the winner decides everything. Will our universe shrink back in a big crunch, like a deflating balloon? Or will it keep stretching outwards forever? This cosmic battle is the biggest mystery of all. Part 6. A big mystery. Trying to understand the dark side. Scientists are like detectives in space, trying to find clues about dark matter and dark energy. They're doing big experiments to find tiny dark matter pieces and see how dark energy makes the universe bigger and bigger. This search could totally change how we think about space. Part 1. Our short time here. What does the end of everything mean for us? Our time here is like a blink of an eye compared to the hugeness of space and time. This can make us feel small, yes, but it also helps us see things differently. It reminds us to value our time and the people in our lives. Knowing that the universe will end one day can encourage us to live our short lives to the fullest. Imagine everything ends. The whole universe gone. What will happen to us? What will be left of humans? Our buildings, our art, even our planet. Poof, all gone. But what if a little piece of us remains? Not our bodies, no, but something else. Think of it like this. Information, like a secret message. Maybe we can put our knowledge, our stories, onto something really, really strong. Something that can last even when stars explode. Or maybe we send it out, like a radio message. A message to the universe. This message, this information, this could be our final act. Like saying, we were here, even after everything is gone. A tiny spark of humanity, still shining in the darkness. So friends, even though the universe might end one day, it's actually quite inspiring, no? It shows us how strong the human spirit really is. Think about it, we are so curious, aren't we? We always want to know more. This desire, this wanting to learn and explore the cosmos, it's amazing. The universe, maybe it will end. But our human spirit, our ability to be awestruck, our curiosity, these things, they can last forever, you know? They can live on. So friends, as our journey comes to an end, we are left wondering at this amazing universe and its powers, no? Even after all our searching, so many questions are still there, like, what exactly this dark matter, this dark energy? And what happens to information, Han? Where does it go? These puzzles, these mysteries, they're like a fire, you know? They keep our scientists searching, keep them asking questions. It reminds us that the universe is full of wonder, so much we don't know yet. So friends, what will happen to the universe in the end? We don't really know for sure. But one thing is crystal clear. The universe is a truly amazing and beautiful place, full of surprises. Our journey through how the universe might end wasn't about being scared of the end, no. It was about celebrating how grand the universe is and how curious we humans are. Think about it. We can actually imagine these huge cosmic events. We can use science to look billions of years into the future. That's pretty amazing, right? It shows how powerful our minds are. We humans can ask really big questions about our place in the universe, and then we try our best to find the answers. The universe can create new things and destroy old ones. This reminds us that our own lives are precious. It tells us to enjoy the beauty around us, to value our time on Earth, and to try and make the world a better place. As we finish our exploration, let's hold on to that sense of wonder. Let's always be curious to learn more. The universe is full of mysteries, and they should inspire us. Because trying to understand the universe isn't just about the universe itself. It's also about understanding ourselves and our place in this grand, beautiful story of existence.
Space. Vast, mysterious, and unimaginably dangerous. Imagine a force so strong it can tear reality apart. A black hole devouring entire stars. Picture a planet wandering aimlessly in the cold darkness with no sun to light its surface. And then there's the ultimate fate of the universe. A terrifying scenario where everything we know ceases to exist. These are not scenes from science fiction. These are real phenomena lurking in the cosmos. Stick with us as we explore the most terrifying things in space that make the universe stranger than we could ever imagine. Let's start with one of the most infamous terrors of space black holes. These invisible monsters form when massive stars collapse under their own gravity, creating a region so dense that not even light can escape. If you were unfortunate enough to fall into one, you'd experience what scientists call spaghettification. Your body stretched into a thin strand of atoms. What's even more terrifying, some black holes, called supermassive black holes, sit at the centers of galaxies, including our own Milky Way, quietly consuming matter over billions of years. And then there are rogue black holes, wandering the galaxy unseen. What if one passed near our solar system? Recent discoveries have shown that black holes can collide and merge, sending ripples through space-time known as gravitational waves. Scientists have also observed high-energy jets of particles being ejected from black holes, a phenomenon still not fully understood. The event horizon, the boundary around a black hole, warps space-time and bends light, creating a gravitational lensing effect. Theoretical physicists are constantly developing new models to understand these cosmic monsters better, including the possibility of wormholes and alternate universes. Imagine a planet like Earth, but without a star. Rogue planets are worlds ejected from their solar systems, doomed to wander the universe in perpetual darkness. With no sunlight, temperatures on these planets plummet to extremes. Yet some scientists speculate they could harbor life deep beneath their frozen surfaces. Could rogue planets be hiding secrets about life in the universe? Or are they just cosmic tombstones, reminders of the chaos in space? Astronomers have discovered these rogue planets using advanced telescopes and data analysis. The potential for life on these wandering worlds remains one of the most intriguing mysteries of the cosmos. Gamma-ray bursts are the deadliest explosions in the universe, releasing more energy in a few seconds than our sun will produce in its entire lifetime. If one occurred within a few thousand light-years of Earth, it could strip away our planet's atmosphere, leaving it lifeless. Scientists believe gamma-ray bursts are caused by the collapse of massive stars or the collision of neutron stars. Thankfully, these events are rare, but the damage they can cause is almost incomprehensible. In 2008, a gamma-ray burst was detected that was 7.5 billion light-years away, yet it was visible to the naked eye. Such events remind us of the immense power and unpredictability of the universe. The Great Void, also known as the Bootes Void, is one of the largest empty regions in space, spanning over 330 million light-years. It contains very few galaxies, raising questions about why it's so empty. Some even speculate it could be evidence of advanced alien civilizations harvesting energy on a galactic scale. Or perhaps it's a natural phenomenon we simply don't understand. Either way, its vast emptiness is a chilling reminder of how little we know about the universe. Scientists have proposed theories involving dark matter and cosmic microwave background radiation to explain this void. Some suggest it could be a result of cosmic inflation in the early universe, creating vast empty spaces. Others believe gravitational forces during galaxy formation might have led to this mysterious emptiness. The Great Void remains one of the most intriguing and unexplained phenomena in the cosmos. Finally, let's talk about the ultimate fate of the universe, the heat death. Billions of years from now, the universe may reach a state where all energy is evenly distributed and no new stars can form. Galaxies will dim, black holes will evaporate, and the universe will become a cold, dark void. It's a scenario so bleak it's hard to imagine, but it's a possibility based on current scientific understanding. However, there are alternative theories. Some scientists propose a cyclic universe, where the cosmos undergoes endless cycles of expansion and contraction. Others suggest the concept of a multiverse, where our universe is just one of many, each with its own fate. Another theory is the Big Rip, where the universe's expansion accelerates to the point that galaxies, stars, and even atoms are torn apart. While the heat death remains a leading theory, the true fate of the universe is still a profound mystery. Neutron stars are the remnants of massive stars that have exploded in supernova. These incredibly dense objects pack more mass than the Sun into a sphere just a few kilometers across. If you could scoop a teaspoon of neutron star material, it would weigh billions of tons. Neutron stars also have incredibly strong magnetic fields and can spin at astonishing speeds, emitting beams of radiation that sweep across space. These are known as pulsars. Despite their small size, neutron stars are among the most extreme and fascinating objects in the universe. Dark matter and dark energy are two of the biggest mysteries in modern astrophysics. Dark matter is an invisible substance that makes up about 27% of the universe, while dark energy is a mysterious force driving the accelerated expansion of the universe, accounting for about 68%. Despite their prevalence, we know very little about these phenomena. Scientists are working tirelessly to understand their nature and how they shape the cosmos. Could dark matter and dark energy hold the key to unlocking the secrets of the universe? Exoplanets are planets that orbit stars outside our solar system. Since the first exoplanet was discovered in 1992, thousands more have been found, ranging from gas giants larger than Jupiter to rocky worlds similar in size to Earth. Some of these exoplanets lie within their star's habitable zone, where conditions might be right for liquid water and potentially life. The search for exoplanets is one of the most exciting fields in astronomy, offering the tantalizing possibility that we might one day find evidence of life beyond Earth. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. Given the vast number of stars and planets in the universe, it seems likely that intelligent life should be common. So why haven't we found any evidence of it? There are many possible explanations, ranging from the idea that intelligent civilizations are rare or short-lived, to the possibility that they are deliberately avoiding us. The Fermi paradox remains one of the most intriguing questions in the search for extraterrestrial life. Space is beautiful, but it's also terrifying. It reminds us how small and fragile we are in the grand scheme of things. From black holes to rogue planets, gamma-ray bursts to the heat death of the universe, the cosmos is full of wonders that both inspire and humble us. But for now, we have our home, a small, vibrant planet in the vastness of space. Let's cherish it, because out there, the universe isn't just strange, it's absolutely terrifying. Subscribe for more cosmic wonders.